Hello again. I hope yesterday went well for you, finding the area and perimeters of the same sort of rectangles. Now, I want you to pay attention to the different shapes, the different perimeters, and how their area may differ. So let's just warm up from yesterday and start with this question. It's asking, what is the area of the green rectangle? And it tells us that the rectangles have the same perimeter. So let's quickly just double check that. Because this is a review, I won't be writing everything down. 7 plus 7, its equal side, is 14. Plus 3 and 3 is 6. 14 plus 6 gives us the perimeter of 20. Okay, so we're starting off with our perimeter of 20. And 5, 10, 15, 20 is going to give us the perimeter of 20 again. And we are measuring in millimeters. So here we go. We want to find out what is the area of the green rectangle. Now, you can use your knowledge of squares and knowing that this is also 5 over here. So you can just go ahead and multiply 5 times 5. The area will be 25 millimeters squared. Now, if it was difficult to recognize it as a square, you can still do the same method we practiced yesterday, which was taking the 20 and subtracting the sides we knew. So 20 minus 5 is 15, and we know that because this is 5. This side is also 5, so it'd be 10. That would leave us with 10 millimeters left to divide from this side to this side. So if we were to answer, we would say that it is 25 millimeters. Let's just take a peek at what the area of the purple rectangle is. 7 times 3 is 21. That did not work out. 21 millimeters. So if you were wanting to build a little garden and you had only 20, well, let's pretend it's meters, not millimeters. That'd be a crazy small garden. Which one would give you, which side lengths would give you the more space to garden in? Pretend these are meters now. Would 7 meters times 3 meters give you the most space to garden? Or would 5 meters times 5 meters? Let's think about this as we go into our scenario next. Okay, so I want you to tell me what dimensions you would give a rectangular dog run, basically a pen, an enclosed space for your lovely dog to frolic in. Now, you are only given 20 units of fencing. So, again, it's not saying which would give the most, which would give the least, but I already went ahead and put in a whole bunch of possible rectangles that have the perimeter of 20. 9 plus 9, 18 plus 1, 19 plus 1 is 20. You can go through and double check. 6 plus 6 is 12, plus 4 plus 4 is 8, 12 plus 8 is 20. So I've exhausted all of the rectangles that can be made from 20 units. I only have 20 units of fencing. Each unit can be separate. So you can see visually here that my dog may prefer different ways to run around. Now, here's my little dog, and I have lots of options in where I can put him. What fence would you choose? Let's use math to figure this out. So, my little blue dog, he is a decent sized dog, as you can see. I probably want to give him a larger space to run in. So, my perimeter of 20 that has the length of 9 and width of 1 gives me 9 square units. Okay, not bad. My perimeter of 20 with 7 of a length and 3 of a width give me 21 square units. That's already significantly more. I think my dog might enjoy running around in the 3 by 7 a little bit more. As you can see, 8 times 2 gives me 16 meters, so not as great. 4 and 6 is 24, and just a little bit larger is my perimeter with a length of 5 and width by 5 gives me 25 square units. Now I have the fencing available. I have 20 units of fencing, so I can make any of these shapes. However, I am wanting my dog to be able to run in a larger space. So I might choose this great shape over here, this square, because it will give me the largest amount of area for my dog to run in, as you can see by the math we've done here. So as you go on and complete your work today, keep in mind how the relationship between area and perimeter can have different effects on whatever you are making.